Okay, we were at the end of part B and we had discovered that the concentration of the magnesium and calcium ions in solution was 9.6 times 10 to the negative 3 moles per litre. Now that figure there is the answer to part B because it asked for what the student would calculate the concentration to be from the titration. However, for us, it's important that we practice stepping now from there to an expression of hardness. And we do this, remember, simply by expressing that many moles per litre in terms of the mass of calcium carbonate that would emerge if that many moles of calcium carbonate were present. So it's very easy. You simply have to rearrange your formula now so that mass is equal to the number of moles you have, that's from the titration, times the molar mass of calcium carbonate. If you put that into your calculator, you'll find that that is equal to 0.96 grams per litre. But what do we express hardness in? Well, we express it in milligrams per litre, so we have to move that 3 places to the right, 960 milligrams per litre, which is also 960 parts per million. Now, from your knowledge of water hardness, you could conclude that this sample of water was very hard. Hard water is classified as anything over 500. Up around 1,000, this is a classic scenario for water that may have come from a bore, maybe towards the end of a long river system where the water's had a lot of time to contact mineral-rich deposits, or potentially from a mine site where calcium and magnesium ion concentrations in minerals are very high. So that's how you would step from the concentration down to an expression of hardness. This question only asks you to be able to get to here, but this is a very important step for you to know. Part C of the question is worth 1 mark. It only has a couple of lines, so you need to be very succinct. Read part C and have a go at it now before watching the next vodcast.